Why do we need subnet mask? Since a IP4 address already gives the information of the network and host, why do we still need a subnet mask? The first octet already specify the network class 1 to 127, A, 128 to 191, B, 192 to 223, C, etc. A, B, or C implies the number of octets for network, respectively, 255.0.0.0, 255.255.0.0, 255.255.255.0, which automatically tells you how many hosts is allowed for each class of network. The IP gives all the information a subnet mask has, and more. Why do we need subnet mask in the first place? If the information a subnet contains is not entirely a subset of that inside an IP, then what else does it contain, or what in addition does the subnet do that require us to specify it independently?
Having IP networks only in class-size blocks was too restrictive and limited the number of networks that could be allowed, the 127 classer networks taking half of the space. Not to mention that having a 24 billion node network is completely unmanageable. Instead, in 1993 classless interdomain routing, SIDR was introduced to allow the networks to be split up. Also, to be clear, the purpose of the subnet mask is to determine which hosts are on the local network and which are outside of the network. Hosts can talk directly to hosts on the same network, but they need to communicate with the router to talk to hosts on external networks.
The first octet already specified the network class 1 to 127, A, 128 to 191, B, 192 to 223, C, etc. A, B, or C implies the number of octets for network, respectively, 255.0.0.0, 255.200, and 55.0.0. 255.255.255.0, which automatically tells you how many hosts is allowed for each class of network. Right, but if someone were to subnet that network, you'd need the subnet mask to know how big a subnet you were in. Yes, with classful addressing, the class tells you the size of the network and allows you to tell whether a host is in the same network as you. But if that network is subnetted, without the subnet mask, how would you know whether another node is in the same subnet as you? Say you're on an Ethernet network. We use classful addressing with subnetting. Your IP address is 1.2.3.4 and you want to reach 1.3.1. Do you use ARP to reach that address? Well, it depends on whether 1.2.3.4 and 1.3.1.1 are in the same subnet. Even if they're in the same network, if they're in different subnets, a router needs to be used. If they're in the same subnet, then ARP should be used. So you need the subnet mask if subnetting is in use, even with classful networks. I think you're confusing subnetting with SIDR actually. Without SIDR, even with subnetting, you don't need the subnet mask between administrative regions. But you still need it inside the network.
A subnet mask is used to do a bitwise operations on an IP address, in conjunction with a network address. If my memory serves me well, you take an IP address and do a bitwise and on it and the subnet mask for a given network. If the result equals the network address, then the IP address is on that particular network. Routers that have routing tables of network addresses and subnet masks can use simple binary maths, which is very fast, if not the fastest for computers to handle, to find out which interface to punt a packet out of.
Except for at Adrian's answer, I'm not sure any of these actually mention why we use the mask instead of some simpler to understand solution, and he only touched on the fact that masking is fast. I mean, why not just specify that you are interested in addresses 192.168.1.200 to 192.168.1.220, or why not just use names like my.address.com for this, just naming each computer instead of assigning numbers? You actually can now to some degree completely remove numbers from routing. Most pieces could handle the kinds of traffic they are sent, but there is still a problem on the larger scale devices. Filtering like this is happening all the time, and it's happening a lot. Masking can be done in hardware, completely eliminating the need to waste time on uninteresting packets, which used to be 99% of the packets you'd have passed through your wire. Now with switched hubs you shouldn't see any that aren't addressed to your machine, again making it less relevant. For a solution that is so easy on the hardware, it is also very flexible. The same hardware can route an entire class and network, 10.x.x.x, or just one or two IP addresses with the same implementation. This is not a replacement for any of the other answers, just a little more info.
Force breakdown. Please assess the